Did a video. Wasn't expecting that. So you can see I'm just sticking these probes in there. You can see, and again, I'm not touching anything electrical. I'm reading my about 122 volts there. So you can see that we now have power to that. If that's off, of course, I don't have that power there. So I'm checking my source. So we do have a source. If say this bulb wasn't working or something like that, I check the line going, so I could check that this wire right here is feeding into this light, and so is this. So if I want to check that load as it's applied, I'm going to go from this wire that's feeding back there to this one, and I should see voltage there. There it is again. Now let's say there was something wrong with it. Maybe the light bulb was hot. Yeah, maybe the light bulb was out. If I walk up on that, okay, my compressor, it's demonstrating my compressor. Okay, my compressor's not running. What's wrong with it? Well, I don't know. Do we have voltage available? Check my load. Yes, I do. Okay, do I have voltage to my load? So I'm going to check the 2 wires feeding to that. Yes, I do. What should be happening? Light should be going, right?
It should be on.
So I've got something going on there. So the other possibility here is, what if it wasn't coming on? I didn't have a. Let me just check. I'm pretty sure those are 24 volt relays. Yeah. So I'm just checking. That's my relay coil on this one. So I know I'm not going to get shocked by this, so I'm just going to pull this off here a minute. As you can see, once I de-energized that relay coil, my light went out. This one here's tied in with that as well, apparently. So, so let's say I walked up on this situation. I said, wait a minute, my compressor's not running. What's going on? Well, do I have power to the unit? Do I have my source? Yes, I do. I have a source. Do I have power to my load? No, I don't. Well, why don't I? I don't know. Let's check across this contact and see if it's closed. What am I going to find when I put this across that contact? Am I going to read voltage or not?
No.
Yes.
Yes.
I'm reading voltage across it. Why am I reading voltage across it?
Because
It's still energized.
It's open, isn't it? Because I took the wire off the coil. The relay's not energized.
Okay.
What do you think will happen to that if I plug that relay coil back in and energize the relay
you
coil?
won't get anything.
My voltage will go away, won't it? Don't try this at home. So now, I know I'm energizing that relay coil, right? So let's see what happens across that closed contact. I don't read any voltage across the closed contact, do I? Yeah, I mean, that's just kind of some phantom stuff right there. Doesn't matter for anything. So what happens when it's not closed? When I open up the contact, I read voltage across that closed contact. So, and then this is this simulating our outdoor fan motor, our heat, which is not on right now, and our indoor fan motor. So let's see. We're calling for cooling. Let's turn off our cooling and see what happens. So we've turned off the cooling. Why is my fan still running? My indoor fan motor's still lit up. Why is it running?
Fan's still on.
Yeah, let's turn to the fan position on here, isn't it? What would happen? So I'm going to have power to that relay coil right now because I have a demand for the fan, don't I?
Mm-hmm.
So there's I'm reading 27.6 volts. So what am I going to read across this contact right now? That's not lit up. Can I put my fingers on that?
No.
No. It should be open.
If it's open, what am I going to read?
No voltage.
Voltage.
I'm going to read the voltage. There it is. So, you know, just because that light's not on, why is it not on? Because it's not telling it, it's not being energized, and the contact is open. So, in a nutshell, these are just kind of the procedures we talked about, how you check these different things. On my transformer, it's giving you the color coding on the face of the transformer right here. And so, this is my common, or my neutral coming in. This is my hot wire on the line voltage, or the primary side of the transformer. So should I be reading voltage right now? based on that circuit that I had and the fact that I know I'm energizing relay coil right there. I know I'm going to get output. If I just go to this thing and so that's going to be my red and green conductors right here. I should read voltage. There it is. And if I've got voltage out, I don't even need to bother to check the voltage in. I have to have voltage in to get voltage out. Yeah. So it's just a natural step of, okay, well, I know I've got input if I have output. So let's turn the fan off. Okay. So that was in cooling. Let's turn it to heat and see what happens. I'm going to turn it back down a little bit. Flip it over to heat. It might come on immediately. It may have a time delay. I just don't know. So if I'm in heat mode, I'm going to be energizing in the thermostat red to what? For heat.
Heat is red.
No. Usually red is the power for the transformer. Green is usually my fan. You can see they actually are using a green wire right here to feed my indoor fan motor relay. So usually the white circuit is my heat relay. So let's turn this up and see what happens. Oh, there it went. Didn't have a delay. Now if I turn it off and turn it right back on, it'll probably delay. So that brought my fan on too on this one because it's probably set up like it has electric heat. You can tell the thermostat what kind of heat you have. And electric heat, it'll bring it on instantaneously. With gas heat, it will just tell the control board I have heat and let it warm up and then bring on the fan. So they're set up a little differently. So that's the reason that bulb's glowing down there too. Huh, I just thought of something else we could do. What was our voltage coming into this thing?
122.
122. And this is a 100 watt bulb right here. How many amps should that be pulling on that circuit? So what's my formula going to be if I want to find amps and I know
voltage,
watts and volts?
Divide the watts by the volts.
The volts by the watts.
Yeah, that's actually the one that spells pi.
Yeah.
So watts divided by volts will equal amps. So let's do that. So we know we've got 100 watts divided by 122 volts. Is that what we had? So how many amps do we expect that to pull?
Well, 80.82.
No, that's a lot of amps. That's the top one right there.
So less than 1 amp.
I'm reading 0.73, something like that.
Well, we rounded up on the voltage.
Yeah, so that was,
Yeah.
it's a little bit
round a
different,
little bit.
but it's in range.
Yeah.
So you get the general idea. So if you put in numbers that are, rounded, you're going to come up with an answer that's close. So we can do that. So we can, we can see, okay, how many amps does that run? So if that was a fan or something like that, you can check the fan motor. By the way, if you check a blower motor in a furnace or an air handler or something like that, you need to check it with the door in place. If you check it with the door not in place, you're not really loading up the blower with air the way that you would with it closed. So you always check, you have to find a wire that you can access with the door on it. So right there we're pulling about 0.26 on that one. That's the wattage on that thing. It doesn't say, does it? It does, it's just kind of faded.
Bulb, yeah, it looks like it's not 100.
It's a 40 watt.
40 watt.
Or we could have, let's see if that works out. We've got, I'm just going to measure the actual voltage that I'm reading right there. So let's see how this works out. So I know this is, shoot, somebody want to hold that up there a little bit. This is sometimes a problem for people too, because you only need three hands. You need 3 hands to do this. Yeah. So we've got 102.3 volts. And we have 0.27 amps. So let's determine the wattage based on that. So that's just going to be amps times volts. So it appears to be about an 80 watt.
What was the
2.7